want to spend a little bit of time talking about simulation in Microsoft Excel, and to begin with a bit of background on simulation in general. There are times when we're interested in the outcomes of a certain scenario, but for cost reasons or time reasons usually, we don't have the opportunity to generate that scenario a large number of times and make actual observations of the outcomes. So if we can do simulation, we can actually see what the results would look like. And simulation is used in a broad range of areas, most often in training. For example, if you want to learn how to land an airplane, well, one way you can do it, or one of the things you can do as part of your training, is to spend some time in a simulator landing the airplane. It's a lot less costly on you if you make mistakes, and you can get to do the landing over and over and over again and practice it under different situations. And each time you go in, you land the airplane, and you can go back and look at how good a job did you do each time. So that's one application of simulation. Well, I want to talk about how we can use simulation in a slightly different way and use Excel as a tool in order to look at outcomes of different situations. You can build models of all sorts of complexity in Microsoft Excel, and simulation is one tool to take a look at multiple outcomes of these models. And I want to look in particular at simulating outcomes from events where, let's say, we know what all the possibilities are. And by example, let's just say we have some scenario where there are 4 possible outcomes, A, B, C, or D. And we know that on every observation, we're going to see one of those 4 possible outcomes. But it turns out that which outcome we see is going to be random. So we don't know which of those outcomes we're going to get. So this is an example of what we'd call a random variable. At every observation, the outcome could have a different value. We're limiting it to just one of these 4 values, but again, it's random. For each observation, we don't know what we're going to get. And let's also say that we do know something, not about which outcome we're going to get, but about the relative likelihood of getting each of these 4 outcomes. And we can capture those in probabilities. So what I'm saying here is that there's a 15% probability of getting outcome A at any given observation, a 20% probability of outcome B, 40% for outcome C, and another 25% for outcome D. And what I've done here is actually specify what's called a discrete probability distribution. I've listed all the outcomes and the probabilities associated with each one. Well, again, on any given observation, I don't know which of the 4 outcomes I'm going to get. So if I wanted to simulate a list of outcomes from this scenario, I could just start to make a list and record my observations. So I know the possible values are anything between or among the choices A, B, C, and D. So, let's say my first choice is A. I'm just going to guess and put down a letter, one of the possible outcomes. And then maybe the next time I look, I'm going to get a D. And maybe I'll get another D. And a B. Then an A, C, and so on. And I can just keep populating this list of observations in this manner. And I can come up with a very lengthy list of simulated observations. The problem that I have is that I have no guarantee, unless I'm being extremely careful as I guess each one, as I just try to pick one out of my head at random. I don't have any guarantee that the relative frequency of those observations in the list on the right is in any way going to match up with the probabilities in the probability distribution on the left. So I've got to do something a little bit differently. I've got to do something that's going to help me select observations in this simulated manner, but somehow keep track of the relative frequency. And what I'll do is I'll go back to one of our basic tools, which is our number line. Because if I remember from my knowledge of probabilities, I recall that the sum of the probabilities of each of my outcomes must equal 1. So how could I utilize this approach? What I can attempt to do is to take my first outcome, A, and I'm going to place it on this number line. And I'm going to place it starting from the 0 end. I'll place it right next to the 0 so that as I start laying my probabilities out from left to right, the first outcome is going to span a distance from 0 to 15%, 0.15, matching the probability of getting outcome A. And then I'm going to allocate another portion of this number line to outcome B. And I'll allocate a portion from 0.15 to 0.35. So there's a width of 0.2, which happens to be the probability of getting outcome B. And then I'm going to, next to that, position outcome C in a space from 0.35 to 0.75 with a width of 0.4, the probability of getting outcome C. And then my remaining space has a width of 0.25. I'm going to allocate that to my last outcome, D. And that interval should match up with the probability of getting outcome D. So what I've done is I've taken this number line, this space between 0 and 1, and I've divided it up among the 4 possible outcomes, but I've allocated the space in such a way that the relative proportion of a space matches up to the relative likelihood of each of the outcomes occurring, as represented by the probabilities. Now, how could I use this? Well, rather than just guessing an outcome off the top of my head randomly and making a list, I could just pick a spot anywhere on this number line between 0 and 1. And whatever spot I pick, it's going to fall into one of these outcomes, fall into the space allocated to one of these outcomes. And if I'm picking that spot truly at random, then what I would have done is randomly generated an outcome in such a way that the likelihood of getting one of these outcomes mimics the probability of that outcome occurring. And rather than just guessing a number between 0 and 1, I can rely on the fact that I'm really not very good at darts. And I can just throw a dart at the number line. Okay. So my dart happened to land somewhere around 0.6. And because I'm not very good at darts, then wherever it falls is truly going to be random once I can get it to fall on the line. And that value of 0.6 is in the space allocated to outcome number C, outcome C. So that first observation resulting from my first dart throw would be an outcome C. So I could then pick another spot on the line by throwing another dart. And in this case, it happens to land way up on the right-hand side near to 1, and it's in the space allocated to outcome D. So I can add outcome D to my list. And I can continue on like this, throwing darts at the number line, seeing where they fall, and allocating an observation based on the space in which that dart falls at random. And that's the approach that we actually want to take in Excel. But how am I going to build this number line thing in Excel in a way that Excel can kind of work with it and throw its equivalent of darts at the number line? And to do this, we're going to make use of another concept. We'll follow the same number line approach, but we're going to recognize the fact that this number line that we've generated and the boundaries between each of the intervals actually represent cumulative probabilities. We start out with a cumulative probability of 0, and then one by one, we accumulate the probability of each sequential outcome. So we go from a cumulative probability of 0 to a cumulative probability of 0.15 at the end of the interval allocated to outcome A. And then we accumulate another 0.2 and get up to a cumulative probability of 0.35. We accumulate another 0.4 and end up at 0.75. And then our last outcome should take us all the way up to a cumulative probability of 1. So now what we want to do is come up with, or have Excel come up with, a number between 0 and 1 at random, and we'll see what interval it's and we'll see what interval it corresponds to. So we're going to generate a random number, and we can do this conveniently in Excel using a function called the rand function. This is the random number generator in Excel. And the formula in Excel is equals rand, and then we open and close parentheses with no arguments inside the parentheses. And this returns a value at random between 0 and 1. And you can express it to as many decimal places as you like. And every time you recalculate this formula by hitting F9 on your keyboard, for example, that random number will change. And we'll see that in just a moment when we switch over to Excel. But let's suppose I select a random number of 0.62, close to where my first dart fell on the number line. Well, what we need to have Excel do is to figure out which interval this 0.62 corresponds to. So we'll start out from 0, and we'll say, okay, is our random number greater than 0? Yes, it is. And we'll go down this list of cumulative probabilities and figure out what gap we're falling in. So I'm going to start at 0, and I'll say, well, 0.62, does it fall in the first gap? No. Is it in the second gap? No. Well, it's greater than 0.35, and it's not quite yet a 0.75. So it falls somewhere in that third interval, which would correspond to our outcome C. And we'll go ahead and generate another random number and do exactly the same thing. That random number is going to fall somewhere on this number line between 0 and 1. And if it's truly random, which we will take the Excel random number generator to be, then each time we generate a new random number, it's going to find a new spot, a randomly determined spot on this number line, but in a proportion that is determined by the probabilities of each of the outcomes. So in doing this manner of matching up the idea of cumulative probability and this random number generator, we can actually come up with a list of random outcomes that match the distribution of the probabilities. So the relative frequency of each of these observations in my list will actually match the probabilities in the probability distribution. So all that remains now is to figure out, how do we get Excel to do what we want Excel to do? How do we create this cumulative probability table? And then how do we generate the random numbers? And how do we get Excel to check to see where the random number falls in the cumulative probability table and return the outcome value that we're interested in? And this is what we'll take a look at next. Okay. The file attached to problem 517 out of our QBA text is really an interesting example of this. It gives us a number of reported accidents based on historical data in a given month in some manufacturing facility, and the probability associated with each one of those outcomes. So let's say a manager looked back at many years worth of historical data and found that in exactly half of the months that were reviewed, there were 0 accidents reported. So the possible outcome of 0 accidents reported occurred 50% of the time. We'll ascribe a probability of 0.5. Furthermore, it was determined that in a quarter of the months that were reviewed, 1 accident was reported per month. Furthermore, in a tenth, or 0.1, of the months of data that were reviewed, 2 accidents were reported per month. And so on. And based on this historical approach, we're building from the relative frequencies of the occurrences of each of these items, we're able to build a probability distribution. And it seems as though it was observed that there was never an occurrence, at least in the historical data that was reviewed, where 9 or more accidents were reported in a given month. So we can eliminate this and say, based on our concept of probability, that there were no occurrences. So the probability of that happening is 0, at least based on the historical evidence. And we can check these probabilities all add up to 1, which is good. So our possible values are here from 0 accidents per month all the way up to 8 accidents per month, and the associated probabilities. And what we've got to do now is to figure out, well, how can I create the equivalent of this number line? Well, I know that I need to ultimately generate these cumulative probabilities. And I'll start out always with a cumulative probability of 0. I'm going to create a new column here that I'll call CP, cumulative probabilities. And I'm going to start at a value of 0. And then each subsequent cumulative probability is going to be the previous cumulative probability plus the probability associated with the next subsequent outcome. So after 0, my next cumulative probability is going to equal 0, the first cumulative probability, plus the probability associated with my first outcome, which happens to be 0.5. So I have a cumulative probability of 0.5. Now I've built this in a formula in such a way that it's always going to take the previous cumulative probability and add in the probability of the next possible outcome. So I'm just going to copy this formula all the way down until I end up with a cumulative probability of 1. So in each case, I'm taking the prior cumulative probability starting at 0 and adding in the probability of each sequential outcome. So now I have my cumulative probabilities, and what I want to do is come up with a random number, look up in this list and see where things fall. Let's do this. I'm going to create eventually a column called random, and then a column called simulated values. All right, simulated values. And here's where I'm going to generate my random number. So my formula is equals RAND, open parenthesis, close parenthesis, enter. And I get a value between 0 and 1. And if I hit my F9 key, that random number recalculates and changes. Okay, so I've generated a random number, and in this case I have a value of 0.227. And what I would do if I were just using this random number is I would look and starting from a cumulative probability of 0, I would go down the list and see what gap this falls into. And clearly a value of 0.227 is greater than 0, but not as large as 0.5. So it falls somewhere in that first gap that would correspond to an outcome of 0, the first possible outcome. Okay, now how do we make Excel do this? It turns out I have to create something called a lookup table. And I'm going to vertically look up in that table to determine what row to belong to, what row my random number corresponds to. And then I'll decide which cell, which column in the table I want to return once I've identified the row. Let's see how this works. I'm going to take my number of reported accidents, my list of possible outcomes, and I'm just going to copy this and replicate it over here to the right of my cumulative probabilities, making sure that my first possible outcome, 0 accidents, lines up with my cumulative probability of 0. And this array, starting from that cumulative probability of 0 and going across, capturing my possible outcomes all the way down to the last possible outcome, this is going to be what I call my lookup table. I'm going to highlight it in yellow, and I'm actually also going to give it a name. I'm going to click in my name box here while I have selected that lookup table, and I'm going to type any name for it. I'm going to call it CP Look. So that's my cumulative probability lookup table. I hit enter, and now I can use this name in a formula. It turns out I'm going to repeat the formula over and over. So rather than having to lock in the cell locations, freeze the cell locations, I'm simply going to type in the name. And Excel will always refer back to this particular array of cells that I've shaded in yellow. Now I need a formula or a function that's going to tell Excel, oh, and by the way, you notice the random number changed again. Anytime we recalculate anything in Excel, all the formula in the workbook update. And it turns out because the value of the rand function changes every time it recalculates, we see these numbers changing all the time. We can force it to happen by hitting F9 on our keyboard, but it also is going to happen every time we update something that causes a recalculation in Excel. So don't be surprised when you see these random numbers moving around on you while the formula is still present in the cell. Okay, so now what I want to do is figure out how do I tell Excel to take this random number, look up vertically in this table to identify the cumulative probability, the largest cumulative probability that my random number is greater than, and then return the corresponding value in the second row of this table, which is my number reported per month. And there's a function in Excel that does exactly that, which is called the VLOOKUP function, vertical lookup. And it works very simply. I'll actually type the formula in here. So my first simulated value I'm going to calculate corresponding to my random number. I'm going to say equals VLOOKUP, L-O-O-K-U-P, open parentheses. And it wants a few arguments here. The first one is the random number in question, or some number. In this case, we're using the random number. It doesn't have to be a random number going into the VLOOKUP function. But in this case, the thing we want to look up is our random number, comma. And then it asks me for the table array. Where is my lookup table? Well, I called it CP look. So I'm going to type CP look. And you notice as soon as I hit that last letter, the K, right where I'm typing, it turns green. It puts a box around the array that I've designated, and it says, hey, is this it? This is what you're asking for? And it is, because that's how I defined it, comma. And then the last argument that the VLOOKUP function has to have is a column index number that says, hey, look, once I've identified the appropriate row in this table, I can return any value in this table on that row that you want. Just tell me which column you want me to return the value from. Well, the lookup table itself only has two columns. We're not talking about the Excel column names, column C or D or E. What we want is in this table, I have two columns, and the value I want to return is the number of accidents reported that's in the second column. My lookup is always going to compare my input value, my random number in this case, to the first column in the lookup table. But I can return the value from any column in the lookup table once I've identified the row. In this case, I want the value that's in column 2 in this particular lookup table. And then close parentheses. I'm going to hit enter, and two things happen. Of course, my random number recalculated again. But for this random number of 0.49, I get a simulated value of 0. So my VLOOKUP function took this random number of 0.49, vertically looked up in this table starting from 0 and said, okay, that number, it's greater than 0, yes. Is it greater than 0.5? No. So it dropped back down to the row that had the next lower cumulative probability and went across to column 2 and returned a value of 0. And every time I recalculated this, it would give me a different value. What I'm going to do is actually not just generate one simulated value, but I'm going to generate a large number of simulated values. I'm going to copy these two cells, the random number and the VLOOKUP function, and I'm going to copy it down some large number of times. So let's say I can do hundreds, I can do thousands, right? I can do as long as I want to drag. So every row here is going to correspond to, it's going to be one simulation trial, one random number that's going to correspond to one place in the, one gap, if you will, in our cumulative probabilities in our number line, and therefore correspond to one particular outcome. I happen to have stopped at a place that will give me 400 simulated values. So for each random number, I now have a simulated value. So a random number of 0.9, well, VLOOKUP went down this list. It's greater than 0, greater than 0.5, greater than 0.75, greater than 0.85. Well, I actually had 0.904, so that's greater than 0.900, but not as great as 0.95. So we drop back to the previous row, go across to column 2, and it returned a value of 4. And this is how we can generate simulated outcomes based on a probability distribution in Excel using the idea of cumulative probability and this function we have called VLOOKUP, which by the way is a very powerful function for pulling information out of a spreadsheet of data. You can just imagine if you could find a way to look up that any index number that's identifying the rows in a table, in a large table of data, you could then say, hey, go to that index number and return the value in column 7 in the table, or anything of that sort. So VLOOKUP is a very powerful function, but we're using it here to just show how we could simulate large numbers of trials of a random variable with random outcomes from some event. All right, so at that point, I'll leave off this discussion. Again, simulation has a lot of applicability in a broad range of fields, but here's one way that we can implement it in Excel.